So dear students, we have discussed about Newton's first law. Okay, now we will discuss about Newton's second law. And to discuss about Newton's second law, as you know from your previous class, from your earlier class also, that the concept of momentum is very needed. Okay, so let me first discuss something about momentum, and then I will move to the Newton's second law. Okay, so actually, to understand momentum, let us inform you that the motion, actually the dynamics of a motion can be described by two physical quantity. One is momentum and another is kinetic energy. Okay, so in this class basically we will discuss about momentum, and about energy we will discuss later. Okay, so the motion of a body is represented by these two physical quantity. One is momentum, another is energy. So from the energy concept we can discuss about the motion, and from the momentum concept we can also discuss about the motion, the dynamics, okay, of a system. And this is the measurable quantity, measurable physical quantity in dynamics, momentum as well as kinetic energy. There are so many physical quantity also, but these two are very important. This is the basic fundamental of dynamics, you can say. One is momentum and another is kinetic energy. So kinetic energy, about we will discuss about this kinetic energy later on other chapter. But and from there we can also discuss the whole motion, assuming the basic quantity as a kinetic energy. But here we will discuss the motion from the viewpoint of the momentum. And there is another difference also, because the momentum is a vector quantity and the kinetic energy is a scalar quantity. Okay, so now let me move further also. Okay, so now let me understand about momentum from some basic examples. Okay, so from our daily life we have experienced so much things, and by using examples one by one we will move to the mathematical definition of momentum. So let me first introduce with you some real life experience or some real life imagination, you can say. So here I am giving some questions to your mind, that you can understand how we can gradually come to momentum, mathematical definition of momentum also. So let me raise a question, very important questions. So if I ask you that when two stones of different masses dropped from the same height on a vehicle, please keep in mind that the stones are falling from a same height, okay, on a vehicle. So which will cause greater danger? Okay, two stones are falling on a vehicle, then you have to say, or you have to think, which will cause greater damage. Okay, and here you can see, if you do the experiment also, that from the same height, if you fall two stone, then always the big stone, or the stone which have greater mass, okay, uh, will cause greater damage. Okay, so obviously the larger stone cause greater damage. Okay, and this is nothing but actually the 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 the, the content, the motion content with the object, with the moving object. The most fundamental quantity with a moving object is nothing but the momentum, and that momentum is obviously proportional to m. I have told earlier that there is two physical quantity in the dynamics, contents in the motion of the object. One is momentum and another is energy. Okay, so this content, the physical quantity that is within the moving object, due to which actually the damage is occurring, and that thing, that that physical quantity which is contained in the motion object, in the moving object, that is proportional to mass actually, and that will cause the damage. Okay, that physical quantity which is contained with the motion, that actually making the damage. So that damage will proportional to m, you can see, and that is actually momentum. Okay, so this momentum is nothing but the proportional to m. Okay, and now if I asked you, obviously since the larger stone with greater mass applies greater force, even though both stones have same velocity when they touch the ground. Okay, because if you fall two objects from same height, then obviously they will reach to the ground with same velocity, and we have discussed this thing earlier in one dimensional motion in vertical motion also. And you know from there that the two stones which are falling from the same height will get the equal velocity. That velocity will does not depend on mass. Okay, but since the larger stone with a greater mass applies greater force, okay, it applies greater force even though both stone have same velocity. So that's why the greater mass will cause the greater damage. Okay, now let me raise another question. Okay, now what I am doing, I am change the height but keeping the mass same. Okay, so if two stones of same mass from different heights drop on a vehicle, which one cause greater damage? And you can see, if you again do the experiment, then you can see the object which is from more height, okay, which is falling from more height, that will cause greater damage. Because if you fall the object from greater height, then what will happen? Then it will gain more velocity when it touch the ground or touch the vehicle. Okay, so here the velocity will be large, but the mass will be same of the two objects, but which will be from the upper height or more height, that will cause greater damage. Okay, so the stone falling from greater height produce greater damage, obviously. Okay, because the stone falling from a greater height will have a larger velocity, as I have mentioned you, and it applies greater force. Okay, so in that case obviously P is proportional to V. Okay, so this motion will, the which motion will have greater P, or which motion will have greater momentum. If you named this physical quantity as momentum, then obviously which a more mass have the more momentum, which is a more velocity has a more momentum. That means which is a more mass, which is a greater mass, that will damage more, and that will have greater velocity, that will also damage more. Okay, so the damage of the car during the motion of the object is depending on two physical quantity, one is mass and another is velocity. So obviously you can understand that the motion of the object, the damage is occurring on the car due to the motion of the object, and within the motion there is two different physical quantity, one is mass and another is velocity, and the damage that is causing on the vehicle, that will depend on mass and also on the velocity. Okay, if you remain constant mass, then greater velocity will cause greater damage, and if you keep constant velocity, then greater mass will damage more. Okay, so now if you change both of them, then obviously which have more m and v, that is actually the product of m, which motion have the product of m and v is more, that will cause the more damage. Okay, that will cause the more damage. So next, let me raise the next question, that if two stones of different masses are dropped from different heights on a vehicle, which cause more damage? In that case, you can see that the stone of larger mass dropped from the greater height causes greater damage, since its product of mass and velocity is larger. So obviously if the product is larger, then obviously it will cause a greater damage. And due to which physical quantity this damaging is occurred, that physical quantity which is contained within the motion is actually named as momentum. Okay, so which have more momentum, that will damage more, and the causing of this damaging of the vehicle is actually called the physical quantity called momentum, and that momentum is mathematically defined as the product of mass and velocity. Okay, so you can now define momentum, that momentum of a body is defined as the quantity of motion contained in it. Obviously the quantity of motion contained in it is a very important word that I was telling again and again, that the quantity of motion contained within it, and that quantity of motion is measured by the product of mass and the velocity, and which of the more quantity that actually was damaging more. Okay, so product of mass and velocity is defined as the momentum, and it is denoted by p. Okay, and the mass of a body is m and velocity is v, then its momentum is obviously p is equal to mv. So this is the mathematical definition or the mathematical measurement of momentum. Okay, and obviously momentum is a vector quantity. Okay, because it will depend on v and m is scalar quantity, so obviously p is equal to mv is vector quantity. Okay, so p vector is equal to m into v vector because m is scalar quantity, and obviously the direction of momentum will be in the direction of v. Okay, so now what is the unit of momentum? And you know that unit, what is the unit of momentum? Here p is equal to mv, as p is equal to mv, you know. So if you talk about the CGS unit of p, okay, then CGS unit p, unit of mass and unit of velocity. So unit of mass is gram, and unit of velocity is centimeter per second, so it will be centimeter second inverse. Similarly, if you talk about the SI system, then it will be kilogram meter per second, because if you talk about the PSI, then it will be the unit of m is kg and unit of v is meter per second, so it will be kg meter second inverse. Okay, and dimensional formula obviously ml t to the power minus 1, because you have this uh, the unit of the dimension of m is m simply, and the dimension of v is, you know, lt inverse, so it will be just m lt inverse. And obviously that I have said earlier, the momentum is a vector quantity whose direction is always in the direction of velocity. Okay, because m is scalar quantity, it will just increase the magnitude of the momentum if you increase m, but it can't change the direction of p. But if you change the direction of v, then automatically the direction of momentum will be changed. Okay, so here are the basic things about momentum. Okay, so now with the from the basic of this momentum, or from the viewpoint of this momentum, we can just now state about the Newton's second law of motion. Okay, and according to the first law of motion, what you know, that if no external force act on a moving body, then it moves with uniform velocity. So whenever a object is moving in uniform velocity, that means no external forces act on it. Okay, so its momentum remains constant. Obviously, if there is no external force, then obviously its velocity is constant, as well as magnitude and direction, so obviously its momentum remains constant. Okay, and hence when the momentum of a body changes, the body must be under the action of net external force. So if you see that there is a change in momentum, then obviously you can assume that obviously there is a net external force. Okay, so now let me state the Newton's second law. And the statement of Newton's second law, as you have read from your very earlier class also, that the rate of change of momentum of a body is directly proportional to the next external force acting on the body. So whatever be the change of momentum, and the rate of change of momentum of the body is directly proportional to the next external force that is given, okay, on the body, and takes place in the direction in which the force acts. Obviously, in which direction the force is acting, the change in momentum will occur in the same direction, and the rate of change of momentum will always proportional to the magnitude, will be always proportional to the magnitude of the force will always proportional to the rate of change of momentum, and the direction in which the momentum will be changed will be always obviously in the direction of force. Okay, so this is the statement, and now in the later class I will discuss more about the Newton's second law, its mathematical form, its application, etc., etc. But now let me discuss about some MCQ till now that we have discussed here. Okay, so momentum is the product of mass and acceleration, the product of mass and velocity, the product of mass and displacement, the product of mass and speed. Obviously the product of mass and velocity, because speed is a scalar quantity. Okay, so this is obviously, you know, that it's a product of mass and velocity. Okay, now the next question is, if two stones of same mass from different heights fall on a vehicle, which one cause greater damage? Obviously stones from a greater height, stones from less height, and B are correct. Now obviously stone of greater height that I have discussed earlier. Okay, next, what is the dimension formula of momentum? You know, ml t inverse 2, t inverse 1, sorry, ml t inverse 1. Option C is correct here. Okay, that we have discussed earlier. Obviously. Okay, so now we will discuss again Newton's second law of motion and its mathematical form, its application, etc. Okay, thank you.